Last row. Perfect. Well, welcome, everyone. Today, we're going to talk a bit more about Databricks SQL. We're going to get under the hood and talk about how we're using AI to get the best price and performance for our SQL warehouse. If you were at the keynote yesterday and today, you heard Reynold, our co-founder, talk about how we're using AI to get really good performance out of our engine. And today, we're just going to go a little deeper, show you what these benchmarks are across a few different categories, as well as show you what these features are and how they work behind the scenes. So just safe harbor statement, everything we're saying is for information purposes only. Some of the features we're showing you are not GA yet, but they will be releasing in the next few weeks. All right, so the Databricks Lakehouse platform already comes with an end-to-end, state-of-the-art SQL engine. Right? You've got a SQL warehouse that already works. If your data is in Delta Lake, you already have a SQL warehouse. Some of you might be already using it, but if you're not, you get a full-fledged SQL warehouse on top of the Lakehouse. This comes with all the features expect on Lakehouse, where you can do all sorts of data analytics and AI in one place. You get world-class performance with data lake economics, as well as you have one source of truth for all your data. Now, when it comes to the warehouse, you've got these 3 or 4 pillars that really matter, right? You want really good price performance. You want built-in governance. This comes to Unity Catalog. You want a rich ecosystem to connect to other tools, like perhaps Fivetran or dbt to get your data into the Lakehouse, or you might be connecting with Tableau or Power BI to do some analytics or BI. And lastly, you don't want to do this in silos. And so data warehousing on the Lakehouse kind of gives you all these 4 elements. Today, though, we're going to focus primarily on the price and performance aspect of the Lakehouse. So there are some challenges when it comes to getting the performance and cost controls you need in a data warehouse. This feels like this impossible task. Do I get lower cost? Do I get better speed? How does it scale over more volumes of data? How does it scale if I get many users? And it can get pretty challenging. And to make this a bit more complex, there's not just like one use case, right? There's multiple use cases, multiple things you're doing in a data warehouse. The first one is getting your data in, ETL or ELT, where you care about low cost, but you don't want that cost to stay low as your data volume goes up, right? If the curve looks up and to the right and exponential, it's really not good, because as you get from 1 gigabyte to 10 gigabytes to a terabyte, you don't want to have exponential costs. So over here, low cost is important. You want the cost to stay flattish as data scales go up, and that's good. Now, speed doesn't matter as much. There's no human being waiting to get the ETL done typically. So if it's 10 seconds or 12 seconds, it's kind of less relevant. Still important, but less important compared to cost. The second bucket is exploratory analyses. This is where you've got data scientists, analysts, PMs who have to analyze the data, either in preparation for ETL or preparation for BI, or they've got a new question and the dashboards don't answer it. And so you have to go and scan tons of data and say, hey, how do I aggregate this trillion row or billion row data set and find these answers? And so again, over here, low cost does matter, because as your user is using the product, they might not put the right filters in, they might not do the right stuff, and the data volume goes up, again, cost could spiral up. But this is not good. You don't want this. You want low cost, but controlled as data volume goes up. Low latency matters as well. You have an actual human being here doing something on their laptop, and you don't want them waiting for hours for a query to finish. And so it is really important for these analyses to also get done relatively quickly. The third bucket is business intelligence. These are your dashboards, right? These are your mission-critical dashboards, Tableau, Power BI, whatever tool you're using. And over here, what matters most is low latency, right? There are actually business users, maybe your board of directors, your CEO, waking up at 8 a.m. on a Tuesday and saying, hey, what happened to my business? And you want the dashboard to load within seconds. But what happens, though, is that as you add more and more users, more queries, more data into your data warehouse, you don't want that latency to increase as the number of dashboards or users or concurrent queries goes up, right? Otherwise, day 1, you show up, great, this dashboard loaded up in 2 seconds. Day 5, with 100 more users, hey, why is it taking 5 minutes? Who messed up here? That's not a good experience. And so what you can see is that there are some different trade-offs over here, where ETL needs low cost with rising data volume. Expertise analysis needs a combination of low cost, but also good latency. And in BI, you want low latency as number of users go up, and you want to keep the cost down as well. So this typically gets very complex. And the solution has been more managing your data warehouse, turning knobs, partitions, indices, et cetera, to get the performance you need. Sometimes you might even use 2 different warehousing solutions in order to get the price performance that you need. And so if you went to the keynote again, we're now in a new era. And we really need to rethink how we build these data warehouse engines to get you the price performance you need across those categories without having to kind of feel like you're turning knobs all day long to get what you need, right? So in DB SQL, we have an AI-powered engine. We've embedded our AI inside the engine in order to get industry-leading TCO and performance. TCO, by the way, is total cost of ownership, same thing as cost. And so the important thing over here is that we're doing this not just in one category, ETL, but across all 3 categories, ETL, expertise analyses, as well as BI. So today we're going to show you benchmarks across all 3 of those things. How are we doing against our friends in the industry? And what are those AI features that are helping us get the performance and cost that makes us worth it? So I'm going to hand off to Mostafa, who is our principal engineer on the performance side.
Cool. Yeah. Hey, everybody. My name is Mostafa. I'm the performance tech lead at Databricks, and performance is my absolute passion. So feel free to come and reach me after the session and ask me anything about performance. So yeah, I'm very excited about the work we've done over the past few months and years. We've made some incremental improvements in terms of performance and overall efficiency. And let's jump into it. So I'm gonna warm you guys up and show you some cool charts and graphs and kind of showing the comparison of where we are compared to the competition. So when it comes to data warehousing, data volume is a common question. I started my use case with a couple 100 gigabytes, a couple of users, and life is great. I'm getting a good cost, I'm getting good performance, and I'm so happy with the current numbers. But what happens as your data set grows? What happens after your amount of data you're ingesting every day or every month become very, very, very expensive? So one of the things we kind of focused a lot at Databricks is basically the value that we provide to our customers. And we provide this value by making sure that the software that we build runs as efficient as possible, and especially at scale. And what I'm showing you guys here is basically, if you're ingesting data, going from 100 gigabytes all the way up to 30 terabytes, what is the cost for ingesting this data? And also what I'm doing, we're scaling the data set size, also scaling the hardware also to get adequate performance. What you can see here in the red line is Databricks where the cost kind of somewhat remains flat. While on the other end, the blue line, it kind of shows almost exponential growth in terms of cost as the data set size grows. So this is a cool chart, but the next I'm going to talk to you guys about how we're actually able to achieve these numbers. So the optimization process, it's not necessarily always easy. If you look at the left here where you have no optimization, you get very poor performance and the costs are very high. The traditional way of doing things, you look at which tables do I need to tune, which tables do I need to optimize, what kind of indexes I need to create. It's a very iterative and expensive process. Do I need to run compaction? Am I missing statistics? What's my file size? It's a never-ending process. And basically what we've been doing over the past couple of quarters is gathering all of this information that's available for the workload and basically automatically tuning it using AI to basically improve efficiency of our workloads. And we're basically, as you can see the arrow, it's this is the direction we're heading, where we have predictive optimizations where it gets applied automatically without having the user to basically fiddle with the system and try to figure out what they need to go and optimize next. One of the cool features that we implemented as of late is Predictive I/O for updates. So updates or merges or upserts is a common pattern in data warehousing where you have an existing set of data and then you want to merge it with new information. And it could be new rows or rows that need to be updated. A common way of doing things in data warehousing is that you do something called copy and write. So files in data warehousing, primarily, they tend to be immutable. Immutable means they're unchanged. So if you need to make changes to that table or particularly a file, you have to rewrite the entire file. So let's say you have a 1 gig file and you want to modify one row. This ends up rewriting 1 gig just for the sake of one row, and this becomes very, very inefficient. There's another way to do things, which is a bit different. It's called merge on read. But basically, relying on the user to figure out which mode they want. Some systems give you the 2 options, but each user needs to figure out which one of these ways of running the merge they need to pick. In Databricks, we have Predictive I/O, which allows us to pick the right algorithm automatically based on the data distribution, the file sizes, and so on. Here's kind of like a more detailed example. So merge into a target table using a source table, and one matched update, one not matched, then insert. This is like your typical merge statement. And using Predictive I/O, we're able to speed up our merge operations by up to 10x compared to the competition. And this is like one of the key parts that allows us to get this 10x cost reduction and great performance that I showed you guys in the earlier slide. By show of hands, how many of you have had issues like partitioning their tables, figuring out like, okay, what columns do I need to partition by? And you could easily end up like shooting yourself in the foot and be like, oh, I had too many files. Oh, it's too slow. Oh, it's a never-ending process. So one of the recent announcements is that we have liquid clustering. It's still a Delta table. Liquid is the name of the technology that we offer. So now you don't have to choose between which columns you don't have to choose between which columns you cluster by, depending on the cardinality. So for instance, if you partition by customer, and today you have, let's say, 10 customers, but tomorrow you have 1,000 customers or 10,000 customers, this will not work with Hive-style partitioning. While on the other hand, with Liquid, it will handle this perfectly well. It's going to manage the file sizes really well, and you don't have to go and tune it, and basically it's not going to be a headache. It's just going to like, you do it once, and then you're going to be able to get the great performance for ingestion and also read queries. So after you've loaded the data into your data warehouse, now you want to basically use it for complex analytics. You want to basically run like big complex queries where you have to like join multiple big fact tables and do all of the exploratory analysis. So at Databricks, we ensure that we're able to deliver like equal or better performance across the board. As you can see here in the chart, from 10 gigabytes all the way up to 30 terabytes, we're able to meet the competition in terms of performance. And the great bonus is that we're able to meet performance, but we're also able to deliver matching performance with 50% lower costs than the competition. So one of the key features that help us achieve that is a predictive I/O for reads. So in Randall's keynote, he was talking about this a little bit, but it's super powerful in terms of like what it offers. So for instance, if you have a query like select star from events where user ID equals whatever, you have to go and figure out, okay, events table is a common table for highly selective queries, and user ID is the column that's usually referenced. The traditional way of doing things, you're going to cluster by this column, or you're going to go and create an index by this column. And creating these indexes and maintaining these indices is expensive. And it's a process that basically you have to go and keep on doing for every table. With Predictive I/O, we're able to triangulate the data that matches your predicates very, very efficiently and really fast. And we end up kind of applying something called lazy materialization. And our AI-driven model is able to pick between a lazy materialization and standard way of scanning based on selectivity and predicate distribution. And as you can see here in the charts, like the traditional way of doing this in a cloud data warehouse, the query takes like 9 seconds. If you go and figure out the indexing strategy that you need to create, you pay for the index, and then you can get it around like 3.6 seconds. With Predictive I/O, you're able to match the performance of the competition with indexing without ever doing anything. So this is like great features that we've added for a very common pattern where basically people usually refer to like finding the needle in a haystack. One of the other features that we've added, like previously in Databricks, you had to run analyze. So analyze is a command that you run in order to basically get statistics or a number of distinct values which are used by the query optimizer. Currently, this feature is in private preview. Soon it's going to be public preview and then eventually GA. So now, basically, as you ingest data, we're going to be automatically capturing all of the needed statistics, which are used by the query optimizer in order to create efficient plans. And in the new mode, it's going to basically literally have no impact on ingestion, and it's going to lead to great query performance. So that's like one of the other steps that we're taking towards basically like having fewer knobs, having fewer things that you have to worry about, even remember. Cool. Next, I'm going to hand it over to Jeremy. Thanks.
All right, so the next bucket is business intelligence. And so these are going to be your dashboards, your sales teams, service teams, executives. They're going to be accessing business intelligence. And kind of the main driver here is latency. And so I'm proud to present these benchmarks for our business intelligence workloads. And as Mostafa mentioned earlier, it's typically you see customers start with just a few users using these dashboards, and it scales up. But as it scales up, latency becomes worse and worse. Our benchmarks this year show just that. We keep latency flat from 2 to over 1,000 users. And in that, a leading competitor of Databricks, they actually 10x the time during that process. All right, now I'm going to show you a demo really quick of just what that looks like. All right, so here we have a serverless warehouse. It's a medium, and you can see there's one active cluster. It can scale up to 40 clusters during this test. And just to show there's nothing going on in this, there's no running queries, there's nothing queued. And we're going to start the load test, and it's going to run a query every 70 milliseconds across a set of users. So as the test kicks off, you can see up here we have the latency at around 1,200 milliseconds. And 10 seconds in, we already have 6,000 queries roughly that have completed. As the more clusters are spinning up, you can see latency is dropping down to less than a sub-second. We're going to be heading down even further. And just to kind of fast forward to the punchline here, at 60 seconds in, we're at 28,922 queries completed. Sub-second, we're at 700 milliseconds. And within that 60-second period, we scaled all the way up to 20 clusters, 19 to 20 clusters within 60 seconds. And how we're doing that now is, I can move to the next slide, is AI-driven autoscaling. This is one of the key features for this. And what that is doing is it's using machine learning to predict the queue. So as thousands of queries become rushing in, we are able to upscale 5 times faster than our 2022 model, and we're downscale 5 times faster than our 2022 algorithms. This has 3 key benefits. It keeps query speeds fast with rapid upscaling. It saves money because you don't have to have 10, 20, 30 clusters running at a time. And you also save money because we downscale faster. Next is our AI-driven query cost prediction. This is a feature called adaptive routing. And what this does is, at Databricks, we see lots of queries, obviously, across a lot of customers. And we're able to predict better and better at what a query is going to cost, what it's going to cost the computer to actually be able to run this query. So this feature, its main goal is to prevent undersubscription and oversubscription. So on the left side, you see that if you had a warehouse that was 60% utilized and you're going to add a small query to that, that's fine. You can add the query. You don't want to queue that query, which would cause you to upscale too early. It would end up wasting resources. But on the flip side, you don't want to wait too late. And if you had 100% utilization, you still add that query, you end up starving queries for resources. So what this feature does is it actually looks at the query, it creates a great estimate of what the query is going to cost, and then it's able to figure out where's the optimal cluster to put that. Does it need to upscale? Does it need to queue? This keeps queries fast by avoiding too many queries being on a cluster, and it also reduces costs by not needing to upscale as often. I'm going to head it back to Gaurav to show some of the benchmarks across the industry.
Thank you. So some of these claims, we couldn't make them maybe a year ago until Mostafa came in, and put all this AI inside our engine. So those benchmarks are pretty cool. I think I was trying the product out even a few months ago, and getting up to scale 22 clusters, practically impossible back then. So if you try the product a few months ago versus now, there's just a large difference in our performance already. So we showed you a lot of numbers and charts. We showed you like this blue line and this red line, which basically shows we're comparing against a competitor. But how do we do across the industry? There's obviously more than one cloud data warehouse that you have an option for. And so we ran many of those benchmarks across actually all of them, right? So this is trying to show you that across the industry, across all the different cloud data warehouse providers, we have us plus 4 of them. We've kept the blue one in here. You've got performance on the top. You've got cost below, right? In both the charts, being lower is better. So if you see a spike, that's bad. We put ourselves at 100%, and then everybody else at relative to us where they are. And you can see as you go up and down the scales, 100 gigs all the way to 30 terabytes. Databricks SQL is kind of leading on performance and cost. And just to keep ourselves honest, if you kind of squint your eyes on the first chart, you'll see that, yeah, there's one competitor in one space where they're slightly better than us. We'll fix that. But these are real numbers. We truly are now leading the industry in performance and TCO across scales. And most importantly, we're doing this across those three categories, right? ETL, exploratory data analyses, as well as BI. Not something we could have claimed a year ago. Now, the cool thing is that we're not doing this by giving you more and more buttons to play with, right? This is happening automatically over time. We have AI inside the product. As you use the product more, the product is going to get better. And just to show you a number, we were behind on concurrency versus one of our competitors. And over the last 2 or 3 years, we've 4x'd to the point where Jeremy showed you the chart. Once you get to scale, our latencies will stay flat even at thousands of users in parallel running dashboards, whereas some other competitors might start having major latency problems, and that solution does not scale. So just to repeat, we now have the best TCO and performance across all use cases, ETL, exploratory data analysis, that's EDA, as well as BI. On ETL, we've got up to 9x the cost advantage. We also have a speed advantage there. When it comes to exploratory data analyses, we can be 50% cheaper, aka 2x cheaper, while still having an advantage on speed, 5 to 10% faster. When it comes to speed on BI, we're up to 10 times faster, and what that really means is 10 times the queries per minute that you can execute in our data warehouses. So to conclude, we believe Databricks SQL is now the only data warehouse that you need. So my question to you as we finish this talk, and we'll open up to questions, is why aren't all your SQL workloads on the industry-leading data warehouse? Thank you so much.